Okay, so we're going to start. We would like to ultimately, this is our goal for today, to answer questions like this. Graph the solution set of the system of inequalities. Remember last time we talked about systems of equations. This time, systems of inequalities. And the only way to get the solution set for those is to graph, because there's an infinite number of solutions. So we are going to warm up by graphing these lines. These are also lines that are going to appear in some of the exercises that we're about to work. So starting with the linear equation in two variables in part A, we're going to, you can just plot points. You can make a little XY chart, right? And for example, you could plug in 0 for X, and you'd get 0 here, and you'd say, okay, Y is 10. That's fine. But I'm going to use the method of getting the slope-intercept form by solving for Y, and using the slope and the y-intercept to graph the line. So for example here, we would like to get the form y equals mx plus b, slope-intercept form. We have this term 5x that's being added to the y. The opposite of adding is subtracting, so we're going to subtract 5x from both sides. So our new version of this equation is y equals negative 5x plus 10. You can't add the 10 and the negative 5 because these are not like terms. All right, remember the number in front of the x is the slope, and we think of it as rise over run. And so the slope that we're talking about here could be interpreted as negative 5 over positive 1 or positive 5 over negative 1. That tells us the direction the line is headed from its starting point. And I always think of this y-intercept here, b, which is 10. It's a pair of coordinates, really, 0, 10. I think of it as the starting point. Notice that 0, 10 is also the point I got when I plugged 0 in for x in the equation. So either way you think about it, you're going to get the same result. All right, so I'm going to graph. This will be my part A graph here. I'm going to plot the point, my starting point, 0, 10. So 2, 4, 6, 8, 10. Okay, so make sure when you're graphing that you're labeling points, please. I'm going to be looking for that on tests. If I ask you to graph, which I will, I'll ask you to graph on paper. I'm going to need to see your coordinates labeled on the graph next to the points. Okay, and then to get another point, we can either go up 5 and down 1, or we could go down 5 and to the right 1. I'm going to go down 5 and to the right 1 because if I go up 5, I'm going to be off my graph, right? So if I go down 5, 1, 2, 3, 4, 5, I would be here. To the right 1, I would be here. Oops. Okay, so down 5 to the right 1. Now, again, I want you to label the coordinates. So what are the coordinates of that point? Yeah, and an easy way to get those, by the way, is subtract the 5 and add the 1 to the appropriate coordinates. The rise is the y coordinate, so subtracting 5 from 10, we get 5. The run is the x coordinate, so that would be a 1. So we would have 1, 5. Okay, and then we're going to connect the dots. Make sure to put arrows at the ends of your line. Okay, and here's the line for part A. Is that what you got? Okay, so if you didn't, common errors include going the wrong direction when you use the slope, okay? Or sometimes people, instead of plotting 0, 10, plot 10, 0 on the x-axis, so be careful with that. All right, part B. So for part B, we already have slope-intercept form, so that's nice. We know our slope is 3. So we can think of that as positive 3 over positive 1, or even negative 3 over negative 1, because if you divide a negative by a negative, you get a positive. So it just depends on which direction we want to go from our starting point. Our starting point being the point 0, 4. All right, so I'm going to plot 0, 4 right here. And let's say I chose to go up 3 and to the right 1. So remember, up 3 would affect the y coordinate, to the right 1 would affect the x coordinate. So we would have the pair of coordinates 1, 7. Or you can do the same thing on your graph. Go up 3 to 7 and to the right 1, and we have the pair of coordinates 1, 7. This is 7 here. This is 4. Oh wait, I went up too much because I have, no I didn't, that's right. No I didn't, hold on. I want to move my 0, 4, I don't like how I had that, hold on. It's too low. Okay, so that's good enough. We'll go to 0, this should have been here, 0, 4. Okay, so now if I go up 3 and to the right 1, we have 1, 7. Make sure you're labeling it in the right order, right? Another common error is to put 7, 1. All right, so there's that line. Is that what you got? Okay. All right, so remember this is the line y equals negative 5x plus 10. This is the line y equals 3x plus 4. Notice the line with the positive slope is going up and the line with the negative slope is going down, which is what we expect. Okay, now let's move on to part C. And I think I need a little more space here. All right, so for part C, we definitely need to rearrange if we want to use slope-intercept form. What would I do first to rearrange this? Yeah, subtract x from both sides, and we get 2y equals negative x plus 6. And then what? Good, divide by 2. Remember, divide everything by 2. So we're going to have y equals negative 1/2 x, right? Because there's a 1, even though it's not written, there's a 1 in front of the x. Plus 6 over 2 is 3. Okay, so our slope we can think of, since it's negative, as negative 1 over positive 2 or positive 1 over negative 2. And our y-intercept is what pair of coordinates? 0, 3. Good. That's our starting point, and then the slope tells us the direction we want to go. So here we're going to graph part C, which is y equals negative 1/2 x plus 3. Okay, so we're going to go to 0, 3. I'm going to move this grid a little tiny bit. Okay, so we're going to go to 0, 3. So 1, 2, 3, 0, 3. Do we expect this line to be rising or falling? Falling, because a negative slope. That's right. So do you want to go down 1 and to the right 3? I mean to the right 2, or up 1 and to the left 2? Okay. So if we go down 1 and to the right 2, we're going to be at what pair of coordinates? 2, 2, that's right. And if you have trouble doing that on the graph, which a lot of people do, remember your y, we're going down 1, so we're subtracting 1 from the y, adding 2 to the x, and you get 2, 2 that way. Okay? All right, so now let's go ahead and connect the dots here. Okay, and that's that line. Did you get that one? No? So check to see where you went wrong. Okay. And remember, if the slope y-intercept method bothers you, you can double check. I would still try it because you need to get used to it, but you can always check your work by just plugging in some points to the original equation and seeing if they fall on the same line. Okay, let's do part D. So for part D, we have to get y by itself. What would I do first? Okay, so we're going to subtract 2x, the x term, over to the other side. So that's going to give us 4y equals negative 2x plus 4. And then what? Yeah, you have to divide by 4. So if we divide by 4 on every term, right, That's going to be y equals negative 2/4, which reduces to negative 1/2, x plus 1. Okay, so now we have a y-intercept of what? What's our y-intercept? 0, 1. And we have the same slope we just did in the last problem, so we can either think of it as down 1 and to the right 2, or up 1 and to the left 2. So I'm going to plot my point 0, 1 over here, my starting point, my y-intercept. Okay, so what do you think? Should we go down 1 and to the right 2, or up 1 and to the left 2? Okay, so down and right, what would be the coordinates there? 2, 0. Good. Now let's connect the dots. Any questions about any of these? All right. So remember, we're going to be referring back to these, so keep these ready. Yeah. Yes, if we had gone the other way, we would have gone to the left 2 and up 2, and it would be negative 2, 2. My line is a little off. Let me see if I can line it up a little bit better. There we go. All right, so if you go to the left 2 and up 1, yeah, you'd be at negative 2, 2. Good. Any other questions? Okay. All right, so now we're going to look at graphing linear inequalities into variables. So instead of talking about all the points that make an equation true, we're just talking about all the points that make an inequality true. Well, we're going to start with this inequality here, and before we actually solve it, and by the way, the only way to solve it is to graph it, okay? So so we can, though, come up with some individual solutions, just not the whole set of solutions because there's too many of them. All right, so can you think of a pair of coordinates, x, y, that would make this statement true? X plus 2y is greater than or equal to 6. Can you think of a single solution? 1 and 3? What is a single solution? Okay, so he proposes that 1, 3 would work. Let's check it out. So if we plugged 1 in for x and 3 in for y, what would we get? 1 plus 6 is greater than or equal to 6, which means 7 is greater than or equal to 6. Is that true or false? It's true. So yeah, he's absolutely right. That is an example of a solution to that inequality. Okay. Can anyone think of another solution to that inequality? 2 and 3. Okay. 2 and 3. 1 and 4. Yeah, that would work too. Let's take a look.
0 and 3.
What about 1,000,000 and 2,000,000? Yeah, that would work too, right? 0 and 3. Oh, that's an interesting one. Let me show you 0, 3. So 0 plus 2 times 3 greater than or equal to 6 would mean 6 is greater than or equal to 6. Is that true or false? Because very good. That tricks people. It's true because it has an or equal to, right? If it didn't, if it was just 6 greater than 6, that would be false. Okay. All right, so all of these are examples of solutions, but we could keep going forever. We would never get them all. So one way, though, to at least get a picture of what types of coordinates will be solutions is to draw the solution set. And the way that we do that is the line x plus 2y equals 6 is a boundary between those values that work and those values that don't work. Okay? So what we do is we draw this boundary on the graph, and then one side of it will be a solution and the other side won't. So we'll shade in the side which has all of the solutions. So our first step is going to be to solve for y, because we want to be able to graph the line. So let's go ahead and solve for y. You should probably recognize this as one of the problems we just did. So to solve for y in this equation, what we do is we subtract x from both sides. We get 2y equals negative x plus 6. We divide both sides by 2. And we get y equals negative 1/2 x plus 3. You remember we just graphed that? Okay. So the second step is to graph the boundary line. Now, yes. So I'm not trying to graph the whole solution set at this moment. What I'm trying to do is graph the boundary between the points that will work and the points that won't. So in other words, we have the points that make x plus 2y be less than 6. Then there are points that make x plus 2y equal 6. And then there are points that make x plus 2y be greater than 6. Okay, this is the line in between those two regions. So what we're going to do is we're going to graph this line, which is the boundary, and then we're going to see the region on one side of it is what we want, and the region on the other side of it is what we don't want. Okay? All right. So, but to graph the line, we want to get it in y equals mx plus b form. So what I do in the very first step always is I replace the inequality symbol with the equals to get the boundary between the two. And we graph it. Okay, so let's go ahead and graph y equals negative 1/2 x plus 3. Look at your graphs from the previous page if it helps, because we already did this once, right? We had the point 0.03 on our graph. Hopefully you labeled it. And what was another point that we got on our graph? 2,2. And the point 2,2. Okay, now, is the boundary line itself going to be comprised of points that make the original inequality true? Yeah, because it's an equals, right? And the original inequality includes two things. It includes a greater than and an equal to. So in that instance, you draw a regular line. But if it did not include, if it was just greater than, we would put a dotted line. And we'll see some examples of that later. Okay, but we draw the boundary line. Now what I'm saying is that this splits the xy plane in half. Right? We have a region up and to the right of the xy plane. Let's call this region A, just so we can talk about it. And then we have a region down and to the left. Okay? And what we would like to know is which of these regions satisfies making x plus 2y greater than or equal to 6. Okay, why is it region A? Okay, we just talked about a whole bunch of points that would be in region A. For example, 1,3 was in region A. There's the point 1,3. 2,3 would be right here, 2,3. 0,3 we already plotted. That's on the line though. And 1,4 is up here also. Okay? So look how all those points that we said were going to be solutions happen to be on one side. That's not a coincidence. Okay, that's because they are values that make the x plus 2y greater than or equal to 6, not less than 6. Okay, but in general, you don't have points that you've already figured out. So what do you do in general? You test a single point. Most people test the point 0, 0 because it's easy to plug in. But you plug in, say, the point 0, 0 into your original inequality x plus 2y greater than or equal to 6, and you see if it makes a true or a false statement. What do we expect it to do? False, because 0, 0 is in B, right? Which we know is not going to be the side that we're getting. But if we didn't know, we would plug in 0, 0, and we'd get 0 greater than or equal to 6, which is false. So what that tells you is that B, the region B, is not in the solution set. But more than that, there's only one other possibility. That means that region A is in the solution set. You don't have to check another point in region A. It's enough to find out that region B is not the solution. So then what you do is you just shade that region. So let's just shade the side of our graph that is going to have all the solutions. So what I'm saying here is I could pick any random point from this side of the line and it's going to make the original inequality true, meaning it's a solution. So that's the graph of the solution set. Okay? Now I'd like you to try one. Is everybody done with this page? No? Okay, I'll wait a sec. Remember, the 3 steps are: step 1, solve for y; step 2, graph the boundary line; and step 3, test a point on one side of the boundary line by plugging it into the inequality. Yes?
Wouldn't you also have to deal with whether or not the line is supposed to be a dashed line?
Yes. So if the equal sign, the boundary line, thank you, if you have a greater than or equal to or less than or equal to, we're going to have a solid line. If you have a greater than or a less than, it's going to be a dotted line because the boundary line is not actually part of the solution set. Okay? All right. So here's the one I would like you to try. Go ahead and work in your groups. People who are watching the video, they can pause the video and try it. Graph the following inequality. Y is greater than 3x plus 4. Okay, so the first thing that I always have you do is just focus on the boundary line. So you replace the inequality symbol with an equal sign, and you solve for y. But we already have it in y equals mx plus b form. In this case, we're lucky y was already by itself. So we're going to just graph this boundary line, keeping in mind that in this case, since this boundary line is where y is equal to 3x plus 4, and we did not have an equal to in our original inequality, the boundary line is not actually part of the solution set. So since we had a greater than, we're going to have to draw a dotted boundary line. Okay? But the boundary line is going to start at the point 0, 4, right? That's our starting point, so let's plot that. And this is what it's going to look like in my math lab. By the way, when you graph your line, you're going to have to use the line graphing function. But if you put in 0, 4, now our slope is 3, which you can think of as positive 3 over positive 1 or negative 3 over negative 1. All right, so which way did you go from 0, 4? Up 3 and over 1, right? Up 3 and over 1. Okay, so remember, if you have trouble identifying those coordinates on the graph, up 3 is the change in the y, to the right 1 is the change in the x. You get 1, 7 for your coordinates. And that's exactly what I get here when I go up 3 into the right 1, 1, 7. Okay, and then you just draw in your graph of your line, connect the dots. Now, one of the downsides to online homework is graphing in my math lab is not the same skill as graphing on paper. And when you take your test, I'm going to have you graph on paper. So I know that it's like counter to our human instinct, but take the extra time and graph it on paper, please, just to make sure that you're ready for the test. It will pay off in the end for that extra 2 minutes. All right. All right, so now what? Oh, well, first of all, I can't do it with, I don't think I can do it with this particular program, but this is supposed to be a dotted line, right? So actually, let me draw it by hand. So, okay, and now the solutions are going to be on one side or the other. So now we test a point. Where's my pen? It disappeared. Okay. Test 1 point. Okay. If you get a false result, that means that you shade the opposite side of the line. If you get a true result, then you shade the same side as the point. Okay, what point do you want to test?
0, 0.
Okay, so usually people test 0, 0 unless the line happens to go through 0, 0, then you can't use that point. You have to pick another point. But if we pick 0, 0 in this case and put it into our inequality, y greater than 3x plus 4, then we get 0 greater than 0 plus 4, which means 0 is greater than 4. Is that true or false? That's definitely false. Okay. All right, so where am I going to shade? Up and to the left or down and to the right? Up and to the left. We do not want to include the side that has 0, 0 in it, so we're going to shade the other side. So every single pair of coordinates that's up and to the left of this line is going to be shaded. All right, now I also want to point out, if your inequality happens to have the y by itself, you notice how it's saying every y value has to be bigger than 3x plus 4? So what that's telling you is to shade the region above the line, because y values are up and down, right? So if your y value is greater than the line, then that means it's going to be the region up above the line. But that only works if the y is by itself in the inequality. Okay? So that's an alternative to testing a point, is to interpret that. If it had said y is less than 3x plus 4, I would have shaded where? Below the line, right? Which is to the right, yeah. Okay, in this case. Not always, but in this case. All right, so that's how you graph the solution set of a linear inequality. But remember, that wasn't our goal for today. Our goal for today is to get all the way to graphing the solution set to a system of inequalities, which means that there's more than one inequality that has to be true in the system. Okay? All right, so here we're being asked to graph the solution set to the system of inequalities, and we have two inequalities. That means we have two boundary lines, and when you have two boundary lines in the xy coordinate system, it's actually going to divide the xy coordinate system up into 4 different regions. And in order to be a solution to the system, it has to work, all the points in that region have to work for both the inequalities. So what we're going to do is we're going to check each region and see if it makes both of the inequalities true. So we're going to start, though, by writing down what our boundary lines are. Okay, our boundary lines are the lines we get when we replace the inequality symbol with an equal sign. In this case, are the boundary lines going to be part of the solution set?
Yes.
Yes, because there's an or equal to, we're going to have solid boundary lines. Okay. Now, we've already rearranged these equations at the beginning of class. What did we get when we rearranged 2x plus 4y equals 4? Y equals negative 1/2 x plus 1. Good. And what did we get when we rearranged 5x plus y equals 10? Good. Y equals negative 5x plus 10. We did that at the beginning of class, so we might as well use that, right? All right, now we're going to graph our boundary lines. They're going to be solid graphs. Okay, so one of the lines, let's go ahead and, let's see, I'll plot this one in green, and I'll plot the other one in blue here so we can tell the difference between the two. So let's graph the green line. We have a y-intercept of 1, so we're going to graph 0, 1. And then the slope, we can either go down 1 and to the right 2, or up 1 and to the left 2. I'm actually going to do both just to be clear. So down 1 and to the right 2 puts us at the point 2, 0. And we also, I believe, plotted negative 2, 2 before. And our boundary line is going to look like this. Oops. So there's the first boundary line. Now I'm going to plot the blue boundary line. Okay, so y equals negative 5x plus 10. So we have 10, 0, 10 is one of our points. Okay, and then our slope is negative 5. So we can either go down 5 into the right one or up 5 into the left one. Which one will work better for us? We don't want to go up, right? That'll be off the graph. Let's go down 5 into the right one. So down 5 will be at 5 to the right one. So here's the point 1, 5. And let's do that again because I want to see if it intersects at a nice even point with this green line. Down 5 and to the right one, oh look, we'll be at 2, 0. So this one also goes through 2, 0. Does anyone know how you would find the point where the two lines intersect? You can, well, if you think you know the point, you can plug the point into both and test it, yes. But if you don't have any idea what the point is, you can actually solve the system, right? So solving the system gives you the point of intersection, and you would just set each, you could use substitution in this case. But anyway, we already can see it's going to be 2, 0. Okay, so now look at how many regions we have here. We have divided the graph into 4 regions, right? So I'm going to name them just so we can talk about them. So let's say that this upper right region is A, this one's B, this one's C, and this one's D, going counterclockwise. Again, I'm just doing that so that I can talk to you about it and you know which region I'm talking about. Okay, what was next? And when we were solving one where we just had one inequality, what was the next step? Test a point. And that's what we're going to do now. We can test 0, 0, sure. All right, so remember the inequalities we had were 2x plus 4y less than or equal to 4. 2x plus 4y less than or equal to 4, which went with the green line. Keep that in mind. And we had 5x plus y less than or equal to 10. 5x plus y less than or equal to 10, which went with the blue line. Okay? All right, so let's say we test, is the point 0, 0 on either of the lines? No, so we can use it as our test point. And we're going to test it in both inequalities. So if I plug 0, 0 into this inequality, I will get 0 plus 0 is less than or equal to 4. Is that true or false? True. Okay, now remember that was the green line. We just found that this side of the green line works for this inequality. Which two regions are those that are C and D? That's right. Do you see how C and D are both below the green line where the 0, 0 is? So we just found that any point in C or D will work for this inequality. Okay. Now, let's test that same point, 0, 0, in this other inequality that's related to the blue line. We would get 0 plus 0 is less than or equal to what? 10. Is that true or false? True. Okay, so 0, 0 is to the left and below the blue line, right? So which regions is that describing? B and C. Do you see B and C are both to the left? Here, let me sketch this in. To the left of the blue line is where 0, 0 is. Yes? Ignore the green. It's hard to do sometimes, but ignore the green line for a minute. If we just had the blue line and I test 0, 0, this would be the side, yes? That I just found works. Okay. All right. But remember, when we have a system, that's an and situation. Both have to work in order for it to be a solution. So which region works for both inequalities? C. Okay, that's the region that works for both. So that's the region we're going to shade. Now, I cannot tell you how many students have come into my office and said, Ms. Hearn, I can't get these right at all. I get them wrong every single time. I shade the wrong region. And I say, are you graphing it on paper? And they say no. They're trying to just look at it on the screen and it's not working for them. So I sit there and I say, okay, let's have you graph it on paper. And guess what? They get it right every time. So save yourself the trip. I mean, I love to see you in my office. That's fine, but you can save yourself the trip if right now you practice doing this on paper, okay? So I have another problem here that I would like you to try at your desk in your groups to help each other out. Graph the solution set of the system of inequalities. X minus y less than or equal to 2, x greater than or equal to 4. And this will be the last thing we do today. All right, so we're going to start by analyzing the boundary lines. These are going to have which? Solid or dotted boundary lines? Solid. Okay, solid. Why? Because it includes an equal to, which means that we are including the boundary line. So we have two boundary lines to consider. One is x minus y equals 2. Which means negative y would equal negative x plus 2, or in other words, y is x minus 2. Did you get that for your slope-intercept form? Okay, good. The other one is just x equals 4. Okay, now, a lot of times people can't remember, is that a vertical line? Is it a horizontal line? What is that? I always say, just plot a couple of points. What this is really telling you is that x is always 4. Y can be anything, and you'll see when you plot those points that gives you a vertical line. Okay, so it's going to be vertical. All right, so let's go ahead and start by plotting x equals 4. Put this too far up again. Hold on. Okay, so plotting x equals 4. It's just going to be 4, 0, and 4, 1, and 4, 2. So you're going to end up with a vertical line. I can get mine to be vertical. Hold on. There we go. All right, and just label at least one point on your vertical line so I know that you know. And I'm going to stretch it out so that it's all the way to the top there. Okay, so now y equals x minus 2. What's the y-intercept? Negative 2. 0, negative 2. And you can use the slope, which is 1, to go up 1 over 1, up 1 over 1. I'm going to actually plot the x-intercept as well, which is 2, 0. How do you find an x-intercept if you want to do it that way? What if you wanted to find the x-intercept? Yeah, let y equal 0 and solve for x. This is an important fact to know because it works for any graph. So if anyone ever asks you for any kind of graph to find the x-intercept, you have to let y equal 0 and solve for x. So 0 equals x minus 2 means x equals 2. But however you come up with it, we need 2 points to determine a line. Now I'm going to plot my line, or graph my line. Okay, close enough. All right, so we have now divided this into 4 regions. We'll call them A, B, C, and D. Okay, for example, for the line x equals 4, A and D are to the right and B and C are to the left of it, yes? So let's go ahead and test the point 0, 0. It's definitely not on the line x equals 4. If you plug it into the corresponding inequality, which was x greater than or equal to 4, do we get a true or a false statement? 0 is definitely not greater than or equal to 4. This is false. So which regions does that narrow it down to for this particular inequality? A and D, right? Because we're not including where 0 is, which is to the left of x equals 4, A or D. Now how about for the other inequality, x minus y less than or equal to 2, x minus y less than or equal to 2, if we plug 0, 0 into that, what do we get? 0 minus 0 less than or equal to 2. Is 0 less than or equal to 2? Yes, that's true. So for the blue boundary line, which was associated with this inequality, we have AB on one side and CD on the other side of that blue line. Which are we saying would work for this inequality? A and B, right? For the blue, just for the blue. All right, so now for the system to be solved, though, it has to be true to both, which would be A. So I would go ahead and shade the region up and above the blue line and to the right of the black line there. Okay? Is everybody good? Mm-hmm. All right, I'm not gonna, well, do I need to take, did I take roll last time? All right, we're good then. You don't need to do roll today. All right, Friday we have a live chat. So either log in at 11 a.m. to the live chat and make sure you type in the box so I know you're there, or you can watch it later at the recorded version. Okay.